Hello friends, welcome to educators.com. I am Preeti Rathi. In last video we have seen arrays and now we will discuss about arrays, pointer arithmetic, and we will check out three-dimensional array also. The topics which we are going to cover are arithmetic operations on pointer, arrays and pointers, then three-dimensional array in C. We can have arithmetic operations on pointer. Now we can create pointer of different type like integer pointer, float pointer and character pointer. When we say integer star x, it means that x is a variable which can hold the address of another variable holding integer value. Float star y means the variable y is pointing to the address of another variable of type float. Similarly, if I'll say char star of z, then that means z is pointing to another variable of character type. So we have taken three variables of different types and three pointers. Then we are holding addresses of those variables in the relevant pointer and we have displayed all the addresses. Then we are having increment operation on the pointer and again we are displaying address. So you can see that when we display this address, that time every next address is will be pointing to the next element. That is, if it is an integer pointer, then the next address will be +2. If it is float, then it will take the size of float and it will be +4. If it is character, then it will be +1. Means when we increment pointer by 1, it actually goes to the next integer or next float or next character. So the increment is not actually by +1, but it will increment it by the size of that particular data type. That again we'll check out later practically. Now we can have arrays and pointers are also related because we know that arrays always are in a continuous memory. So if I have a pointer pointing to the 0th element of the array, then using a loop I can iterate array through pointer also. The way we did here, that j is pointing to the 0th element of the array and then in for loop we are iterating from 0 till 5 and here we are displaying address of j as well as value at the j. So first time it will display the value as value at the 0th location of array. Then we are incrementing pointer. So it will go to the next element. It will increment by the size of integer. So it will point to the next element of the array. Similarly, whenever we'll do j++, every time it will point to the next element of the array. And this way we can traverse through the whole array. So using pointer we can traverse through the array. Now when we have j equal to ampersand num of 0, even ampersand can be removed because when we say 0th element, it will take the address of 0th element into j. If we'll give the array name itself, so it means address of the 0th element. Then we have one more declaration over here, that when we have ARR of 2 of 3 of 1, that is a three-dimensional array, so it can be expanded like this. That is ARR plus 2 star on that, then plus 3 again star on that, then plus 1 and a star on that. This way pointers and arrays are related. If it is a two-dimensional array, that is ARR of 3 and 2, then is equivalent to ARR plus 3 star on that and then plus 2 and star on that. Similarly, if it is one-dimensional array, then it is equivalent to ARR of ARR plus 4 and star on that. So this way we can expand array into the pointers. We can have three-dimensional array also, where it is an array of two-dimensional arrays. If I'll say array of 3, 4 and 2, that means I got three arrays of two-dimensional array, which each array will have 4 rows and 2 columns. So we can even have initialization of this array, and this way we can display the array. It means three-dimensional array is an array of two-dimensional array. Two-dimensional array is an array of one-dimensional array, whereas one-dimensional array is an array of actual elements. Now we'll check out all this concept practically. Here we are having hash include stdio.h and conio.h, which are the header files. Main is the entry point of our application. Now here we will declare 3 variables and 3 pointers. Say integer I is a variable and star of j is a pointer of the same type. Then I'll take another as a float j, or say float a, and I'll make it as a star of b. Means b is a pointer pointing to the float type of variable. Then I will take character ch, and I'll have another pointer as star ch1. Now we will do the initialization. Say we have I equal to 10, then a equal to 1.5, then we'll have ch equal to some character. Now we will have j equal to ampersand of I, means j is holding address of I. Then b will hold address of a. Similarly ch1 will hold address of ch. This way we did initialization. Means 3 variable we have initialized, integer, float and character, and then 3 pointers we have initialized to hold the respective variables. All 3 variables we have taken of different data types. Now here we will display all 3 addresses. If I'll have address of integer, now this is before increment we are displaying this. Say before increment, address of integer will be j. Then we will display before increment address of float, that is stored in B. Then we will display before increment address of char, and that is stored in ch1. Now once we will display the original addresses, and then we are going to have increment operation on all the pointers, that is j++, means we are incrementing them by 1, b++ and ch1++. Then again we will display all the addresses, that is after increment address of integer will be j again. Then again we will display after increment address of float is b, and then we have after increment address of char, which is stored in ch1. So like this all addresses we will display. Now if I'll execute this, so you can see here address of integer was 24 so which has become 65826, means it is incremented by 2 because size of integer is 2 bytes. Float is 20 which has become 24 because size of float is 4 bytes. Here we got 65519 which is now 20 because size of character is 1 byte. This shows that when we increment any pointer, it is not incremented by 1 but it will be incremented by the size of that variable to which it is pointing. Because pointer points to the address, so when we increment it, it means go to the next integer. So it will skip the size of integer or float or character depending on to which type of variable it is pointing. Now we will check out how arrays and pointers are related. If we have a one-dimensional array with say 5 elements, which I will initialize here itself to some values randomly. Now we know that arrays are always stored in a continuous memory. So I can take a pointer, say integer star of ptr, and I'll make this ptr to hold address of 0th element of the array this way. Now first time it is holding address of 0th element. Now through for loop I can iterate this, I can increment the pointer and can display array, because right now it is pointing to the 0th element. If I'll increment pointer, it will skip the size as of integer size, means it will point to the first element, then it will point to second element. So I can always use pointer to traverse through the array. For example, if I'll have a for loop where I'll go for some variable which will be initialized to 0, say I equal to 0, then I is less than 5 and I plus plus. Now here we will display the value using ptr, that is %d and we'll just say star of ptr. Now if I'll have ptr plus plus, so it will point to the next element, and this way we will be able to display the whole array. If I'll execute it, we can see that array is displayed over here. Now if we want to display the address also, so we can have, this is the value, and then we'll have address equal to %u. Now this address will be stored in ptr. So if I'll execute this now, you can see here 11 addresses here 20, incremented by 1 means it will go to next integer, which is nothing but the next element into the array. So it will be 22, 24, 26, 28, and similarly the values are displayed over here. So this way we can traverse through the array using pointer. Now when we have any element, when we fetch, for example, suppose I will say I just want to find out fetch the third element. So I'll say element, say for example I'll have third element equal to %d, and again I'll display that third element using expansion. Means here I will have ARR of 2 because array starts with the 0, and same can be displayed this way. It is star of ARR plus 2, because ARR actually gives the address of 0th element. On that we are doing plus 2, so we are at the third element and then we are putting star on that. So this way we can have expansion of array. Now you can see here 23 is fetched. So the both meanings are same only. This way we can expand one-dimensional array. If it is a two-dimensional array, then similarly we can have ARR. For example, if suppose we have ARR 1 of 2 and say 2, which is equal to 4 elements I'll put over here. Now if I want to display the fourth element over here, that is second row and second column, so we can have from two-dimensional. Now again I'll display twice the values. So we expect after expansion the same value should be given. So I'll have ARR of 1 as 1 and 1, which is now same as of initially. We just have to do ARR plus 1 where we are going to the second row. Now on that we have to make star, then we have to wrap this again and make it as a plus 1 and just give a star over here. So this is the expansion of two-dimensional array. If I'll execute this, so you can see here ARR 1 plus 1 on that star is given, then again plus 1 on that star is given. So value can be retrieved with the 2 stars. If I'll execute this, you can see from second dimensional we are getting 4 4. So again the same value. So this way we can expand two-dimensional array. Same is true with the three-dimensional array also. Now we'll check out three-dimensional array. Three-dimensional array can be initialized this way. Suppose I have 3 arrays of two-dimensional array which will be 2 by 2. Then as we have discussed, three-dimensional array is an array of two-dimensional array. So we have to give the values this way. Say I have first row as 2 and 3, then I got another row as something like this, and this is the one row we have completed. Then we'll have second row this way, and finally we'll have the third row like this. And this is the end of array declaration. Now here also we can expand the array in a similar way. If we have from 3-dimensional array, now I'll display the element, say ARR of 2. Suppose I'm going for the second array, first element, first row and first element of it. Then here again we have ARR of 2 plus 2. On that one star we can put then we'll have plus 1, one more star will add here, then again we'll have plus 1 and one more star. So 3 stars will be required for 3-dimensional array. Now at this level, as the statement of declaration is over, you have to give a semicolon. So you can see here 78 and 78. So this way we can fetch the element and we can expand array just like the pointers. So this is about 3-dimensional array, arithmetic operations on the pointer, and we have seen how the arrays and pointers are related, how to traverse through the array using pointer. Now in next tutorial we'll talk about strings, which is nothing but the array of character. Thank you.